Hello guys, so I am planning to do a super revision series in which I'll be covering 6 years of papers within the span of next 6 weeks, and I guarantee you that I can upgrade your results just this 1.5 months. I can guarantee you to upgrade your results from one level higher from which you were in. Now let's say you are at an S pass, I can guarantee you a C pass. If you are at an F pass, if you are going to fail, I can guarantee you will get an S if you follow along with my 6-year past paper series and also work with me. Right, there is only limited time. You got only 7 weeks left. Right, only 7 weeks left. If you can follow along with me for the next 6 weeks, if you put the work, you will definitely be able to upgrade your results, and you definitely don't want to get an F. Right, you have to upgrade your results. If you are at a D pass within the next 6 weeks, you can go for an A pass. If you work hard enough. Okay, so let's start off with today's lesson. I will be discussing all six essays and 50 MCQs within the span of next 6 weeks. I'll be releasing one essay per day, and at the end of the week, I'll be releasing the MCQ review as well. Today, we'll start off with 2019's logic gates and boolean expressions. So, 2019 question, before you start this recording, before you start this video, I suggest you first finish the paper, do the paper, try it by yourself, and then we can jump into the question. Now, if you haven't done it, pause the video, do it, and then start this video. Okay, now, the boolean function known as the majority function takes n binary inputs and outputs 1 if majority, at least half of the inputs are 1. Otherwise, it outputs 0. Let us consider the case when n equals 3, which is 3 input majority function, whose inputs are a, b, and c, and the output is z. Okay, so what are they saying in this question? They are telling the majority, if a, b, C. Collectively, if they are greater than 1, right? Meaning if the majority, like let's assume these two are 1 and this guy is 0, then what will the output be? Output will be 1. So this is the scenario they're telling. If majority of them are 1, if majority of the inputs are 1, the output will be 1. Okay? And now they are going into the question. Draw the truth table for 3 input majority function. Okay. Now first of all, let's look at the truth table. Okay, so first you have to follow this order. Always remember, when you're filling in a truth table, you're going to go with 4 zeros, right, and 4 ones. Then you're going to go with 2 zeros, 2 ones, 2 zeros, and 2 ones. Then the next one is going to be 0 1, 0 1, 0 1, and 0 1. Now, the output, what are they saying? What is the question saying? If the majority of the inputs are 1, only then the output is 1, right? Now, we'll check the initial condition. At initial 0 0 0, what will the output be? 0. Why? There are no 1s, and the majority should be 1 in order for the output to be 1, but there are no 1s, so the output is 0. Next up, we have 0 1 0 0 1. In this case also, the output will be 0. Why? There is only 1 1, right? If you have at least 2 1s, the output will be 1. Any other cases, output will be 0. Next, you have 0 1 0. In this case, what can you guess the answer to be? 0. Next up, this case 0 1 1. What do you think the answer will be? Answer will be 1. Why? The majority is 1. In this case, majority is 0, right? Majority means most, whatever is occurring the most. In this case, it's 0. Therefore, output will be 0. Then you have this 0 1 0 1. In this case, you have 2 ones. The majority is 1. Therefore, the output also will be 1. Now, in this case, 1 1 0. Output will be 1. Majority is 1. Next up, you have 1 1 1. The majority is 1. This is the complete truth table answer. The order, the things, key points you have to remember. This question is an easily scorable 15 marks question. 15 marks means for the whole paper you are getting 7.5 marks. Okay? This is an easy scorable marks. Most of the students go for this. This is a must do question. Okay? So focus, listen, remember the pattern. How do you go? 4 zeros, 4 ones. 0 0, 1 1, 0 0, 1 1. 0 1, 0 1, 0 1, 0 1. This order is the input order for 3 input terminals. If you have 3 inputs, this is the order that you have to follow. This is the input order. Whatever the question it is, always the inputs will be in this format. The outputs may vary depending on the question, but the input will always be 4 zeros, 4 ones, 2 zeros, 2 ones, 2 zeros, 2 ones, 0 1, 0 1, 0 1, 0 1. Okay? Now, since you got the picture of the output, what are they saying in the next? Now, this is the truth table. Now, we have finished the first question. The next part. What does the next part say? Using K-maps, derive a simplified expression for the output Z in the 3 input majority function. Okay. Let's look into K-maps and how they work. So now, we'll draw first a K-map. I'll draw a K-map and show how it looks like. Okay. Now a K-map, the main rules of a K-map is only one can change at a time. Okay, look at this. I'll first start off with 0 0 and you can follow this order. You can remember the order and you can follow it. 0 0, 0 1, 1 1, 1 0 and 0 1. Now if you see in this K-map, at first these both are zeros, then at the second instance you have 0 and then 1. Only the B terminal, this B coordinate is changing. Then in this what is happening? B coordinate stays as 1, A coordinate changes to 1. It was initially in this condition it was 0, now it is 1. Now the next state, you have A is 1, it stays as 1, B is changing back to 0. Okay? Then in this you have C's conditions, C is 0 and C is 1. Now, how do we map whatever we have drawn in this truth table to the K-map? So, if we are going to fill whatever is in this into the K-map, this is how you do it. Now you look, A is 0, B is 0, C is also 0. What is the output? Output Z is 0. Now, in this condition, look at this. This holds the place of A, this holds the place of B. A, B, A, B, A, B. Okay. Now, A is 0, B is 0, C is 1. Sorry, C is also 0. You have 0, 0, 0. What is the output? 0. This is how you fill the K-map. You have a truth table, you want to fill the K-map. You first write the coordinates as it is. Like this, if you remember this also it's fine. But remember, the main key point is 2 of them don't change at the same time. Only one coordinate can change at one time. Meaning it was initially 0 0, 0 1, 1 1, 1 0. Okay? Now, since we have filled this, let's go look into the next one. A is 0, B is 0, C is 1. What is that condition? A is 0, B is 0, C is 1. What is the output? 0. Put 0. Next one. You have A is 0, B is 1, C is 0. Where is that? Over here. A is 0, B is 1, C is 0. What is the output? 0. Fill 0. Next one. A is 0, B is 1, C is 1. So what is that condition? A is 0, B is 1 and C is 1. This place. This is how you find the place where you are going to fill. What is the output? 1. So you're going to mention here 1. Next, A is 1, B is 0 and C is 0. Where is that? This place. A is 1, B is 0 and C is 0. So this box, right? So in that box, what is the output? 0. Okay? Next, you're looking at this. A is 1, B is 0, C is 1. A is 1, B is 0 and C is 1. So you know that it's going to be in this column, right? Since this is already filled, and you know the coordinate of C is what? 1. So it's this box. In that box, what happens? You get this output. So mark there 1. Next, you're looking at this line. So in this line you have A is 1, B is 1, C is 0. A is 1, B is 1. So you know it's in this column. C is 0. So that means it's going to be this box. What is the output? 1. That's how you fill the K-map. Next one. A is 1, B is 1, C is also 1, output is 1. A is 1, B is 1, C is also 1. This box. Output is 1. Alright, now since we have completed the K-map and the truth table, right, let's go into the next part. The next part says, so the K-map, that question, it doesn't only say the K-map, it says what? The K-map derive a simplified boolean expression for the output z in 3 input majority function. Now, since we have mapped this table, truth table, into the K-map, we don't need to use this anymore. We don't need to use this fellow anymore. It is easier for us to use the K-map. Why? This is very big, the K-map is small and it's easy to understand. Okay? So let's raise this. Redraw the K-map. Okay? And I'll show you how to derive a boolean from the K-map. Now mainly you have 2 types of derivatives from the K-map. Okay? So mainly you have 2 derivatives. One known as the SOP and the other known as the POS. Okay. So let me just brief through them. Okay. So POS means product of sums. Product of sums. So what does product of sums mean? Meaning you have multiplications of sums. Meaning like this. Example, A plus B plus C multiplied by A bar plus B plus C. Right? This is a product of sums. This is POS. Now, I personally use SOP more than POS. Okay? So, POS is that. Okay? Now, in the other questions, they will ask both. They will ask the POS and the SOP. In that case, we'll discuss both. In this case, I would go with the SOP. I'll teach you the derivations and simplifications as the past papers come. Okay? Now, SOP, it is like this. Sum of products. Okay? Sum of products. Now, sum of products means what? You have A dot B dot C plus A dot B bar dot C. This is an example for SOP, sum of products. Now, how I'm going to derive SOP and POS from this is like this. Meaning these guys, they work like this. Okay? The zeros in the table, the zeros, okay? Zeros will give you the POS. The ones will give you the SOP. Okay? Remember this clearly. If you can differentiate them very well, you can easily score marks in this. Okay, zeros for POS, ones for SOP. Okay, now how do I collect these ones? Now there are 4 ones here, right? Now how I mark in K-maps is like this. You have to have either a single one or a pair or a quadruple. It goes in the 2 powers, either 2 to the power 0, 2 to the power 1, right? 2 to the power 0 is what? 1. 2 to the power 1 is 2. 2 to the power 2 is 4. So it should be in this format, meaning I can either circle one individual one or 2 pairs at the same time, or if there are 4 ones in a line, then I can circle that as well. Okay, so the circling system is like this. I have to circle this. Now if I have 4, I can't circle them like this. I can't circle them like this. I have to maintain. Now I told you, okay, 4, you can circle 4, but doesn't mean you can circle them like this. How we are going to circle this is, you are going to take it pair by pair, because the circle should be either vertical or diagonal, I mean horizontal, not like this. This does not have a proper shape. It should either be a circle like this, a circle like this. Okay, either one of these 2 types of circles, or they can be a square circle like this. If you have 4 ones here, you can circle them at once. Since this is not a normal shape, how we are going to circle them is like this. I am going to circle these 2 together, and these 2 together, and these 2 together. You might now ask, why did I do 3 circles? I could have just circled this once, and then I could have just circled this fellow and this fellow. Now to get the most simplified expression, now they are telling what? Derive a simplified expression, right? To get the most simplified expression, I need to have the most number of ones in one loop. If I have only this guy and this guy, I will have more terms in the final expression. I will show you how that works, okay? I will draw both and I will show you the examples and I will show you how it comes. Look at this. Now for this loop, how do I get the expression? If you see this loop, okay, what are the terms that are not changing? A, B, B, right? This is A, this is B. This is A, this is B. Now what is A changing? A is not changing. Here also A is 1, here also A is 1. Then what am I going to put? A. In this case, now we have looked this, now you look this way, now you have looked this way. Is C changing? C in this loop, C is remaining 1. Right? Does it change from 0 to 1? No. Then what am I going to put? Dot C. From that loop. Now you can mark an arrow from this loop. And you guys, if you did not get it, you can try this by yourself. Pause the video and try it by yourself. Okay? Then after that, in this, A, B. What is not changing? B is not changing in this case. See here, A is 0, after that A is becoming 1. In here B is 1, B remains 1. That means what? You can write B. And check this way, C is 1 and still remains 1, no? In these 2 numbers, this one and this one. If you take this loop, B and like C does not change, right? C will only change in a vertical circle. It's 0 and 1. So here it will be C. Now I'll take this vertical loop. From this vertical loop, what can you say? A and B are not changing now. See, in this and this term. Is A and B changing? Is it going this way? If it goes this way, A and B will change. Now see, in these 2 loops, A and B changed and we got 2 different expressions. In this loop, A and B is not changing. But what is happening to C? C is changing. And what can you say? From this loop, since A is 1 and B is also 1, you are going to get what? A dot B. Okay, that now all these are what? Products, right? Multiplications, no? So now I am going to write the SOP or the simplified SOP. Okay, the simplified SOP is going to be what? A dot B plus B dot C plus A dot C. This is the most simplified boolean expression you can derive from this schema. Let's assume you took these circles as individual circles. Okay? Right over here. Okay, let's say you took this as 1 and this as 1 and this as 1. What do you get from this? What is not changing in this specific circle? In this specific circle, nothing is changing now. You have only this term, then you are going to have A, B and C. Now in this case, right, B is 0 but the output is 1, right? So A dot B dot C, right? Nothing is changing now. Nothing is changing. In this circle, is there any changes? Is anything moving? No. Then from this circle, you are going to get A dot B dot C. But B is 0. The output is what? 1. So this guy is 1. This guy is 0 and this guy is 1. How can you have a dot and get 1? 0 into 1 is 0 and 1 into 0 is still 0, but the output is 1. Then what are you supposed to do? You are supposed to add a bar to this guy. Now 0's bar is what? 1, right? So you are going to get 1, 1, 1, which is going to give you 1. This is how you do if there is a 0 in the K-map. Okay? Now if you see, this one has how many terms? 3 terms. Then what is happening to our expression? Our expression is becoming bigger. Do we want that? No. We want it to be as simplified as possible. Our initial answer was what? Our initial answer was A dot C plus B dot C plus A dot B, right? Yes. So, shall we derive that from this? How are we going to derive? What are the loops that we are going to use? Try to use as many pairs as possible. Try to make sure that they are always in pair. Make sure that they are not alone. Nobody likes to be alone, do they? You guys might have been single throughout your A-level life, but it sucks. It's really sad. Okay? So make sure that they are always in pairs. So this guy is in a pair, this guy is also in a pair. If you can make pairs, try your maximum to make pairs. If you can't make pairs, example, if there is like this and everything is 0 except this one guy and this one guy, then what are you going to do? You can't cross them diagonally. So then you are going to circle them individually and then you are going to find the SOP or POS. You can, with ones you can find only the SOP. If they are like this, then you can go ahead, separate them and keep. But if they are next to each other, it's not good, right? You are next to somebody and you've been next to them pretty much for the whole question and you are not making a pair. It's really sad. Don't do that. Make sure you make them a pair. Now, we got this, right? This is the most simplified version. Now, what are they saying next? They are saying, construct a logic gate circuit for the 3-input majority function using NAND gates only. Okay. Now come, let's see how to do this. Now, most of them, they either use NOR gates or NAND gates. That's how the final questions usually work. So for this part, you have to be little bit creative. Okay. Now, if you are going to use NAND gates, what you are supposed to do is make two big bars. Now, if you have studied boolean expressions, you know that A is equal to what? A double bar. Why is this? Let's soon draw a truth table and check. Right? What are the inputs A can have? 0 and 1, right? Then A bar will be what? 1, 0. Then the bar of A bar, like meaning A double bar is going to be what? 0, 1. Okay? So now you get the same as A, no? If I erase this, what happens? A and A double bar are having the same outputs, meaning same inputs. They are not any different, no? Then what can you say? A and A double bar are equal. So anything in a whole, if you have, you can put the double complement law and put it together. Okay? Now, next part. What are you going to do with this? Why did I do double bar? Because NAND gates usually have bars, right? NAND gate, the function is what? AB means you are going to get an output A dot B whole thing bar, right? You can see something similar to that, right, over here. Right, we'll work on it. Now see, we're getting closer and closer to the answer. Now, you might have, if you have studied this chapter, good. And if you are just coming for the revision, very good. You might have known something called De Morgan's law. Let's say you have a bar, okay? And if you want to break the bar, what are you going to do? You are going to change the sign. What is the opposite sign of this, or the different sign? What are the two main signs you have? Plus and dot, no? So this dot becomes a plus, right? And the bar breaks. So here there is going to be a bar, and here there is going to be a bar. Clear with that? Okay, so this is what? De Morgan's law. Morgan's law. Remember this, this is important, this is very useful, and it will always come in your questions. And the other form is A plus B bar. How can you break it? You guys try this, pause the video, try it by yourself, and then continue. Okay? A plus B bar, how do you break? What is the opposite of plus? Dot. So A dot B, and you are going to break the bar. Now, let's continue with the question. This is, both of these are part of De Morgan's law. So, if we break the bar here, what happens? A dot C bar. I'll write it a little bit lower. A dot C bar dot B dot C bar dot A dot B bar. This whole thing is going to have a bar on top. Now, how are you going to do this? Now you are very close to the answer. You can literally see the answer. How can you create this? A, B, C like this. Now extend the lines, and now your problem is 100% solved. Look at it. A dot C, right? Jump. You can get A dot C over here. Simple. Next one. B dot C. Okay. He is also solved. Next one. A dot B. See where the lines are starting. This line is, now I will start from here. Okay, how I got A dot C. Here line is starting from here. This place is coming to A, and this is C. So A dot C bar. Next one, B, jumping, coming, joining to this. C is coming, getting joined to this. So you get B dot C bar. Next one you get? You get A, this is coming, jumping, going through this. This guy is jumping, is coming here. What do you have? A dot B bar. Now how do you bring all these together? and add dots in the middle. Connect them all to one NAND gate. Now what's happening? All these are getting connected to one NAND gate. Then what will the output be? You will have these things all together as dots. See, this is the output you will have. A dot C bar dot B dot C bar dot A dot B bar, the whole thing bar. So this is the final output you will have. This is what they asked you to construct. So now you can say what? This and these are the same, right? This and these are the same. Why? Because if you do, now you can do De Morgan's opposite function. If you have something like this, right? You can do what? De Morgan's opposite function. Same thing, reciprocal. Right? You can bring these two together. How? A dot B, and you can put a bar on top. You saw the sign changed, the bar got together. Same way you can do A dot B, the bars are broken, you can bring them together, change the sign and write it like this. So for this function, you can bring them together, right? If you bring them together, what will you get? You will end up getting this guy, right? A dot C plus B dot C plus A dot B under one double bar. Then what did I say earlier? A bar, A is equal to A double bar. Then what can you say? You can cancel this and write this whole thing is equal to this, only without the bars. You don't have to necessarily write that. The moment you draw this, the teacher or the marker will know, yes, this student has understood the lesson. I can definitely give him the full marks. Now if you do this and if you follow along with me, if you have followed along with me, 15 marks, meaning 7.5 marks from your full paper is with you. This is actually an easy question, right? So if you did not understand any part of this, you can drop a text to me. This is my number. Anytime you want, you can drop a text. I will clear your doubt. Okay? You guys, if you want, you can drop a text and follow along. Work hard. You can definitely increase your results. You still have 6 weeks. If you work hard enough, if you put the effort, you can definitely upgrade your results. I know people in the last 2 months, they went from C's to A's. Some guys, they went from W's straight away to C's. Right? They got C's. They were in W level. Right? They were like, bro, I'm gonna fail for sure. But then what did they do? Last 2 months, they worked like hell. They worked around 10 to 12 hours a day. Right? So they really put in the effort and they got really good results. It's really worth it. For 2 months, you're gonna work hard and your life's gonna get settled. Imagine you get into a good university for free education. Sri Lanka has free education. It's really good, right? So work hard, follow along the sessions, and see you at the next class.